Technically, based on the classes that I know all of you have had, well, with maybe one exception, you should know what that graph is. It's definitely a graph. It's kind of two parabolas. No, not W. It's a circle centered at -3, 4 with a radius square root of 45.
Yeah.
We did that in geometry. Chapter 9, section 8. It was a long time ago. So we have to find dy dx and the slope of the curve at 3, 1. So if we know it's a circle, pretty much any slope is possible on this thing, right? I mean, any slope of this could be anything. And so it's very important where they actually ask. And you notice 3, 1 actually does, work out fairly well in there. And so, how are we going to do that? Yeah, probably. Well, your two options are you multiply that all out, or we could use chain rule. So the 2 goes out, write it down, and take it down a power. And now what? Take the derivative in the inside, which is 1 dx dx for this one, right? Okay. Plus. Why don't you try that one for a second while I help these other individuals? So now what? Yes?
Okay, you're going to write down a 2 because you're taking the exponent, then it's going to be parentheses y minus 4 parentheses 1 dy dx.
So you take the derivative of the inside now, which is 1 dy dx equals y0. Yeah, derivative of 45 is 0. Now what?
Now we're going to subtract the dx.
Yeah, that's just 1 dx dx time stuff. That's gone. You could. I personally wouldn't because I'm looking ahead, but you can. What's that? I probably would. I mean, this is going to happen eventually, and I would probably just do this right now. Because that cancels, that's still 0. So we've got x plus 3 with basically nothing left on it, right? I mean, that's just what it is. Plus y minus 4, which is still times dy dx, and it equals 0. Now what? Because what's our goal, really? Yeah, get dy dx by itself. So this x doesn't have a dy dx on it, and neither does the 3, so let's get them out of here. So subtract x and subtract 3 from both sides. So y minus 4. And the reason we're doing that is y minus 4 is still attached by multiplication to dy dx. Divide what? Yeah, get the y minus 4 out of there. Divide by it. There's your derivative. Say that one more time. Well, what you could have done is kept the parentheses around it and then put the, like, subtract the whole thing. But then the negative would have distributed anyways. So either way, or you could have kept it out front. That's what some people do. They would leave it negative and then x plus 3 in parentheses. Either way works. It's the same thing. Yep. Good question. And so that's our derivative, right? It is, we were told to do that. And now we have to find the slope of that curve. It's really not a curve, it's a circle, right? But that does arc, right? So you put 3 in for x and you put 1 in for y. And so we got negative, so we got a negative 3 minus 3. It's just a coincidence that they match, right? Because x is 3 over y, which is 1 minus 4. So negative 6 over negative 3 is 2. So what's 2 again? Of what? Yeah, the slope of that tangent line at 3, 1 as it hits that circle, right? There you go. Yes? I technically took off the parentheses because we didn't need them anymore. And so I subtracted them separately. But if you left the parentheses on, you would just subtract the whole thing. But then it would look more like that when you subtract the whole thing. And if you distribute the negative, it's the same thing. Yeah. Yeah, so the only difference of today, dy dx's are still there. But today we had to use chain rule. It's the first time we actually did it. We kind of did it with trig, but not with the actual chain rule that most people think of as chain rule. But it still works out, not too bad. So any questions about that one? Now we are going to do the tangent line and the normal line.
There is no such thing as angle.
What should I do? What do you have? Well, let's change it that way. Pi over 6, pi over 3. Pi over 6 and pi over 3? Oh, that's a better problem anyways. Is there still a 2 there? So yours is just that. Awesome. I love it. Now what? You have a lot of options, but there's one fairly smart move. Yeah, get the 2 out of there. Otherwise, you're going to have to take it along with that sign the whole way through, and guess what? You're going to end up dividing by it anyway. So get it out of there. So divide this side by 2. Well, dividing by 2 is the same as multiplying by a half, right? So in other words, we've changed it. The problem has changed to that, right? All right, so we're off to a good start here. But now we have to determine the tangent line. So I'm going to determine the actual line itself. And to determine a line, I need a point, which I already have, pi over 6 comma pi over 3. That's a point. Well, I also need what else? Slope. Because please do not forget this. I don't know why it is so easy to forget this, but this is huge. That's how you get the equation of lines quickly, instead of having to fight for them so hard. It's right there. You need a point, you need the slope, and you're good. We've got the point, let's go get the slope. And we do that, obviously, by taking the derivative. But how do you take the derivative of sine of x times cosine of y? Yeah, unfortunately, it's product rule, right? So here we go. Write down the first one, sine of x. Any dx, dx, or anything like that? Let's face it, it's kind of lucky. Even if you mess up with a dx, dx, it goes away anyways, right? But try and keep it straight. Times the derivative of cosine, which is very good, negative sine, leave the angle, right? And then times the derivative of the angle, which is dy dx. Now, a lot of people just stop and say equals 0. But you got to remember, you're not really done with product rule yet. It's a plus. You got to flip things around. So cosine of y, so you write down the second one. Should I write another dy dx?
No.
No. But now I have to take the derivative of sine of x, which is cosine of x, and then take the derivative of the angle, which is 1 dx dx. Do you want me to stop writing that now?
Yes.
Okay. As long as you feel comfortable, I will stop. Equals. Again, I give you a constant. I should probably give you one pretty soon that doesn't have a constant over there, so you got to work a little bit more, but it's really not that much more. Can I go ahead and multiply these and make them say negative sine squared over here?
No.
Why not? Yeah, different angles, right? X, Y. They might be the same, but probably not. And in fact, we know they're not. Well, you can clean it up a little bit, I guess. Negative sine x sine y dy dx, and then plus cosine y cosine x equals 0. So basically, when I say clean it up, I kind of got rid of all those parentheses, so it didn't look quite as scary, I guess you would say. I would actually probably do something that you're not thinking of at this point. You're probably telling me to subtract the cosines. I would actually do something slightly different. No. I'm not big on negatives, so can I add that other term over to the other side? Then everything would be positive, wouldn't it? So add that over there too. How come dy dx can't be on the right side? Just add this whole term over to the other side. Add the whole thing over. You agree it cancels on this side? But then you got to add it over here. Oh, they cancel. Now, could you have done it the whole subtract the other way? Yeah. You would add a negative over a negative. It would have worked out the same. Yeah, get dy dx by itself. How are you going to do that? Can't subtract it, but I can divide. There's your derivative. This is another case where I could rewrite that. This is pretty much the exact same problem we had the other day, by the way. I could write this as cotangent of y and cotangent of x. But again, what do we got to do here? We got to put stuff in. So, yeah, that's probably not a good idea, is it? So, let's substitute things in. So this top would be cosine of, well, what's y? Pi over 3 on your page? Is that what do I have it written right? Okay. Pi over 3 times cosine of, all I'm doing is substituting in now. X, which is pi over 6, all over sine of x, which is pi over 6, and sine of y, which is apparently pi over 3. Once I do this calculation, what's it going to give me? Slope. Thank you. Slope of this particular line at pi over 6 comma pi over 3. So, of course, everybody's favorite. So pi over 3, right? And what's the ordered pair there? Yep. Very good. And the other one is pi over 6. That's this one. Yeah, it's just the reverse of, 3 over 2, square root of 3 over 2, just so everybody knows it, and 1/2. Which one's cosine, which one's sine? First one is cosine, alphabetical, yep. So cosine at pi over 3, well, pi over 3 is this one, so which one's cosine's the 1/2 up here, right? So where am I going to write this? I'm running out of room. We'll write it, here we go. So it's 1/2 times cosine at pi over 6. Well, where's pi over 6? Right here. Cosine is? Yep, square root of 3 over 2. All divided by sine at pi over 6, square root of 3 over 2, times sine at pi over 3. Oh, I did that. Wait. I did it the other way around. Oh, no. Yeah, I did it right. 1/2. Boy, look at that. Yeah, that's one of those strange forms of 1. Boy, that's awesome when you do that. Yeah, you gotta love when you do that much work and you get 1. And you really must love it when you do all that much work to get 1 and you're not done. Nope. Can I erase the stuff in the middle here? All right. So here we go, tangent line. Y minus. What's y1? Y1, pi over 3. Equals slope, which is 1x minus pi over 6. There's your tangent line. Normal line is almost the same thing. It's so close. But the normal line is, remember, the one that is perpendicular to that, but also goes through the same point. So it goes through the same point, so it's y minus pi over 3. It's still going to be x minus pi over 6. The only difference is you've got to deal with the slope. How do you know it's -1? Yeah, opposite reciprocal, right? So yeah, it's very close to the same. Your slope's just -1. The tangent line's the top one, the normal line's the bottom one. Yes? Because of the point that we were given, your point on your paper was apparently pi over 6 comma pi over 3. Yep. Any questions? Yes? Normal is perpendicular to the tangent line, but it goes through the same point. So you can keep using the same point like we did here, pi over 3, pi over 6. And so to take your slopes, you just do the opposite reciprocal like we've been doing. Perfect. Yeah, if it was 1/2, it'd be -2. Yep. Anything else? All right.